Hey, and welcome back to another Learning Java 2D Game Programming video. So in our last video, we made sure that our NPCs cannot spawn on unavailable tiles. And when is a tile unavailable? Well, when it is either unwalkable or it contains scenery that is unwalkable. So that works quite well. None of our NPCs spawned in the water, and when they pick a new target to walk to, they pick an available target. But unfortunately, they are currently not very smart, so say that there is a lamp in the way, like here. Well then, I guess you'll just be standing there forever. Probably starving to death. So we're gonna help our little NPCs today by implementing some pathfinding. We're gonna use the A-star pathfinding algorithm, and I'm not gonna go into much detail on how that works because it's gonna take too long and I'm not an expert on the subject. However, I'm gonna post a link to a video in the description that will explain it all to you. A video by Computerophile. So if you've never seen them before, do check them out. They have a lot of cool videos explaining stuff. But I will just roughly go over how it works so that you have some idea of what we're implementing. And I'm just gonna bring up the editor. All right, let's say that we're standing here and we want to go to here. Well, the algorithm, it uses something called a node. So we need to represent all of this with nodes. It's really easy for us since we have this grid system. So each grid square is a node. This is the start node, this is the target node, and these are all nodes in between. So what we do is we start by opening up our start node, and then we evaluate all of these neighbors. So all of these 8 neighbors get evaluated. We compute a cost for moving to each of these nodes, and we do that by looking at 2 values. One is the move cost to the tile. Let's say that grass tiles maybe have a move cost of 20 and dirt has a move cost of 10, so you would prefer the dirt over the grass. But then there's also the heuristic, which is the distance to the target node. So that also gets weighed in to this evaluation. So this is of course much closer to the target node than this is, so probably it would still choose this one. So after it's evaluated all of these, it looks at the one with the lowest score, and then it jumps to this and does it all again. Looks at all of that tile's neighbors and computes a score. And also, whenever you move to a target, you also add the total cost of where you're coming from. So you're going to accumulate a cost that will be larger and larger because you keep the history with you on your way. And that makes it so it doesn't choose to go backwards. So that's just quickly how this is going to work. And in order to do this, I'm just going to do some small stuff first. So here you can see in this map, we can see which tiles are walkable because they are green, which are unwalkable because they are red. But I would also like to be able to see if they are pathable. So if we can use them for our pathfinding. And by that, I mean, I also want the tiles that are unavailable, that have unwalkable scenery, to be red. That way I can see if we have made our map so that we have some pocket somewhere which is unreachable or things like that. So let's just do that first. I think we can do it rather quickly. I'm gonna head over to the game settings, render settings. Here I'm gonna duplicate one of these. I'm gonna call it pathable. I'm going to set it to be false so we don't render it by default. And then we need a getter for that. Alt insert getter pathable. So now we have a setting for it. Let's just go over to the state editor UI render settings. Just gonna duplicate one of these. I'm gonna call the label pathable. I'm gonna say render settings get to pathable. All right, so now we have a render setting and a way of toggling it on and off. Now let's go to the renderer. All right, so for simplicity and time's sake, we're gonna use this same visual, but let's do it like this. If render settings get pathable, get value. Why would it think that I want to set value in this if statement? Get value. There. If render settings get pathable, get value. Then we want to do this, and we are going to refactor this, but we need to change this boolean first. So tile is available. So if the tile is available, then draw green. If it's not available, draw red. But we don't have this, and we're probably gonna need to give it the grid X and Y. So let's just create this method, tile is available, inside of game map. And actually we have, let's see, where did we do that? Here, get random available location. We are doing the inverse here. So I guess we could, if you just cut that out, and I've said if not tile is available, X and Y. And we want the grid X and grid Y, obviously. Okay, grid X, grid Y. So if not, this tile is available. So we need to implement this, and this is what we had, but this is of course the wrong order. So now it's available when the tile is walkable and the tile does not have unwalkable scenery. Then it is available. Okay, good, that should work. Let's hop back to the renderer, and now that these are almost the same, you can do refactor. I'm gonna say extract method, and I'm gonna call this render path overlay, maybe. And then it says that no exact method duplicates were found, but a very similar method, and you say accept signature change and then say replace. Now these both use the render path overlay, but they have different ways of getting the boolean whether should be drawn green or red. And that ended up here. All right, great. Let's just check that out. See that it still works now that we changed it a little bit. I'm gonna load this up. If I get pathable, then now you can see all of these are not pathable. Here is something, and if we're unlucky, something could be spawning there, right? Something could be spawning here and they couldn't walk out because the pathfinding wouldn't let them. So just gonna check that my map is fine, but these are green, so they could walk in here if they wanted to. Just gonna move it a little bit just to help them along. I'm also just gonna check that this still works, and it does. Great. Just gonna save and exit. So now that we can render that, I guess we'll be on with the pathfinding. So go to your map, new Java class. I'm gonna call this Pathfinder. So first of all, let's make that class, that node class that we will be using. I'm gonna make a private static class node, which will implement comparable. And this comparable forces us to implement compare to. I'm gonna call it node that. And you'll see why we do this in a minute. So what do we need to store here then? Well, as we talked about before, we have this private int move cost to a node. We have the private int heuristic. We are gonna keep the total cost, which we will be calculating, and a reference to the parent node. But on top of this, I'd like for our nodes to also know which grid X are you, and which grid Y are you? So let's make a constructor. It's going to take in the move cost, the heuristic, not the total cost or parent, but the grid X and grid Y. Which means that maybe I'll just rearrange those a little. There. All right. Now that we are comparing, we can say integer.compare. I'm going to say total cost with that dot total cost. Maybe we want to say this dot total cost. Compare this with that. All right. And I'm also going to make a helper method to get a position out of this node. So I'm going to say public position, get position. And I have been debating with myself for a long time now whether I want my position class to know about grids. And I'm still not sure that it's the best idea, but we are starting to do the whole conversion thing in very many places now. So I think I'm going to put it in position for now, and then we can move it somewhere else. I'm thinking the other candidate is maybe the game map, that you give the game map a position and it gives you some sort of grid back. Let's do it in here at first. So helper methods to get the grid position of a position. I'm going to say grid X, which will be, we need to cast it to an int. And then I'm going to say X divided by game.sprite size. So the reason why we're not rounding this grid position is, of course, because of how indices work. So in our arrays, they start at 0 and they go to size -1. So we never want it to round up to be size, right? That's why we do that. Grid Y. And there we go. And now that we can get grids out of them, let's also make a helper method to create a position from them. This will return a new position of this grid X times game.sprite size and grid Y times game.sprite size. And this position will always put you in the upper left corner of a tile. So if you want to be in the middle, you need to add half of this sprite size as well. There we go. Now we can get some help. This makes it easier here because now we can just say return position dot of grid position, grid X and grid Y. There we go. Our node class is done. So let's move on to the actual pathfinding. And I'm going to make this a public static list position, which will be the path. Find path. So we need a start position, a target position, and a reference to the game map on which we are finding this path. All right, so now let's start by making a priority queue of node, and I'm going to call this open, new priority queue. This is why we implemented compare to and the comparable interface. That's because this collection type priority queue, it will always keep itself ordered by that compare to method. So it's going to make sure that whatever this returns, it's going to order by that. So the one with the lowest score is always going to be at the top. So we don't have to think about that. So that's nice. And then I'm just going to have a set for the nodes that are closed. I'm just going to import these classes. There we go. And then we need the actual node map, so a node representation of our tile map. I'm gonna initialize that to be the length of game map get tiles dot length game map get tiles 0 dot length. So now it's the same size. And then let's just keep a reference to the current node that we're going to evaluate. Now let's initialize this node map. So the first thing we're going to do is we're going to calculate the heuristic for this, for the node that we're initializing. And we know this because we have the target position. So the heuristic is going to look like so. The absolute value of x minus target dot grid x plus the absolute value of y minus target dot grid y. So this will give us the distance between these two grid positions. So let's make the node that we are initializing. And I'm going to say, actually, let's just give it, first it wants a move cost. So let's give it some hard-coded value, and we're going to look into that later if we want to weight them. And then the heuristic, and then the x and the y. So this is the entire node. So the first thing we want to check is if tile is available. We actually want to know if the tile is not available. Then we want to immediately add this node to the closed set. So we never look at that. And then the node map, you put the node in the node map at the right position. So now we have initialized our node map entirely. So let's get a reference to the start node at start grid x and start grid y. Let's just duplicate that, call it target node. And I'm going to say target grid x and target grid y. All right, so let's first add the start node to open. And then make a do while loop. While not, open dot is empty. So for as long as we have something in the open, let's do this. So the first thing we're going to do is we're going to set something to our current reference, and that's going to be open.poll. So if you've not used these types of collections before, the poll gives you what's at the top and also removes it from the collection. There's also one called peek, which gives you the reference to the one at the top but does not remove it from the collection. So we have gotten out whatever's at the top. Let's make sure to add it to closed so we don't look at this again in the future. And first we are gonna check if we are at the end. So if current equals target node. So if we are at the end now, then let's just extract the path from this current node. Let's alt enter and create that method. So this is going to give us the list of positions, which is the path. So first I'm going to initialize a list. And then I'm going to say while current dot parent isn't null. So we are traversing our nodes. We are going from node to the parent, to the parent, to the parent, until we get to the start node. And then I'm going to say path.add current get position. And then let's make sure that current is equal to current.parent. So we are saying that this reference now points to the parent of the reference before. Important to note though is that this is going to give us the path in the wrong order. So our start position is going to be at the bottom and we want it to be at the top, so we have to reverse it. And we have a helper method called collections.reverse, and then you just pass in the collection you want to reverse, and then let's return that collection. So this is extracting the walk path, and now we can use it. But let's move on. So this is if we happened to be the target node. But if not, we need to check all the neighbors. So for int x is equal to current grid x minus 1, x is smaller than current, grid x plus 2, x plus plus, and then the y. All right, so what do we want to do if we're in here? Well, first, let's make sure that we are within bounds. Since we have the game map, we can use that method that we have. So if we are inside the bounds, let's calculate stuff. First of all, let's get a reference to this neighbor that we are looking at x and y. So if this neighbor is inside of the closed set, then just continue. Don't calculate anything. But if it's not, let's calculate some cost. The calculated cost will be the neighbor heuristic plus the neighbor move cost plus the current total cost. So like we talked about before. Now, if this calculated cost is smaller than the total cost stored inside of our neighbor, and the neighbor has a total cost if we've looked at it from another tile before, but it can also be new. So if open doesn't contain the neighbor, then we've never looked at it from anything before. So if any of these are true, we want to set these values. So the neighbor.total cost is equal to the calculated cost, and the neighbor.parent is equal to the current node that we are looking at it from. And then let's just say if open doesn't contain this neighbor, then let's add it. All right, and that is it. But if we've made it down here, if we've made it through all of this and we never got to the target node, so we never extracted the path, that means that the target node is unreachable. So that would be if we have a pocket or something like that in our map. So what will we do in that case? And I'm actually going to return a list of these start position. So you're basically going to get your own position back, and then it'll say, oh yeah, you got to the target. All right, so this should be it. I'm just gonna close out of that for now, and to be able to test this, let's go to the AI wander state. So this is currently what is handling all of the movement or the targets and things like that. I want to change the name of this to path, and I am going to store a reference to the target. The reason why I'm doing that is because we are going to look down here. I'm going to say if target isn't null and current character get position is in range of target. So the problem with path.get0 is that our closest target or our closest point on the path is always going to be 0. So whenever you reached your first point, it's going to be like, oh, you arrived, which we don't want. So that's why we have a target reference. All right, and then let's go to this update, which we will change a little bit now. So instead of looking at the path, let's check if target is equal to null. That means we don't have a target, so we need to get one. I'm going to get a list of position, path. I'm going to say Pathfinder, find path. We need a start position, which is the current character get position. We need an end position, which I'm going to say is just state get random position. and then it wants the game map. All right. So if path is not empty, if it isn't empty, and you can get rid of this line, so I thought, there we go. If the path is not empty, then I'm gonna say target is equal to path get path.size -1. So we're getting the last position from our path. And then I'm gonna say this dot path dot add all from the path. All right, now we've checked that. I'm gonna do this. So if we've arrived, then we want to stop. Otherwise we are moving. But if we are, we need to first check so that the path isn't empty. If this current character get position is in range of path.get0, so our closest position on our path, then we've arrived at that path, so let's get rid of it. I'm going to say path.remove 0. And then unfortunately this might mean that we remove the last path or the last position in our path. So we need to check again if path isn't empty. And if it isn't, let's just move to that path get 0. All right, let's try this out. I was gonna see 27 minutes, oh my. All right. As you can see, no one's stuck. They are currently not considering what tile they are walking on, so they're just taking the shortest path. But the most important thing is nobody is stuck, so the pathfinding is actually working. As you can see here, before they would just stand and look across the pond forever and ever, and now they are actually rounding it. Except for that one who is sort of standing there for some reason, and I'm not sure why. All right. I'm just gonna press Y a couple of times. If you remember, we added this feature, this debug feature of speeding up our game so that we can look at it. And they're all walking just fine. So it would be fun to try to add some different values, right? Maybe that they would prefer to walk on dirt or on concrete over walking on grass. But I don't think we have time for that today, so we're gonna do that in another video. But there you have it. Our AI is smart enough, or our NPCs are smart enough now to avoid the obstacles. So thank you so much for watching. You can see I'm defeated because there are so many sick people here. Thank you so much for watching, and I will see you soon. Hej då.